morning, everybody. So first of all, the title as advertised in the brochure kind of worried me because it breaches the truth in advertising requirement, but apparently that doesn't apply to Italy. Oh, by the way, to clarify the harassment policy, you are allowed to harass yourself. And being an Italian and a member of the ICON Italia Association, I am allowed to harass Italians in general and organizers of this conference in particular. I think that's a footnote in small print to the harassment policy. So, what I wanted to title this talk was Bad API Design. The organizers apparently decided that was too negative a note to start a conference on, so what they printed in the brochure is Good API Design. Unfortunately, I'm not qualified to speak on that. I'm very good at bad API design, so that's what I'm focusing on. And so actually you can use that to think about good API design. Just do exactly the reverse of what I'm talking about and you'll be great. Plus, I have to compliment my fellow organizers for teaching me yet another way to guarantee bad API design. I hadn't actually thought of coffee deprivation. Just sit down to design your API or anything else without an espresso in the morning, which is apparently the experience many of us had this morning. And I think I can guarantee that even if you avoid what I'm going to be talking about, your design will be pretty bad. But still, I'm not focusing on that because I've never considered not having a few espressos before starting like light in my morning. So that's something I learned today. All right. Let's preliminary. Why is this a problem? Well, think about it. Forget the title, correct or incorrect of this talk, and think, okay. Oh, I'm doing a new project. What am I thinking of? Well, I want it to do a lot of stuff. I want it to be bug-free. I want it to run like grease lightning, scale up to a bigazillion simultaneous user. I may, not me personally, but a lot of people care about user interface looking nice and user experience flowing smoothly. And of course, very important, it needs to be secure. Keep the user privacy, and then looking to the inside, I want elegant, well-maintainable, clear code, and so on. That's what 99.9% of software design, including me, are focusing on, and there's so many things. What's missing? What do we all kind of fail to think of from day one? Think about it. And what all of these things have in common, except the security part, is that they're all best achieved by incremental workout. You can't just sit down and design everything from the heavens down to earth, design for 3 months and then start coding. Just doesn't work for any of these things. The only thing that you cannot do incrementally seriously is security. That needs to be designed in from the start, but everything else start from a little corner, build toward a center, keep adapting in a very flexible, agile way. That's best for you. And so there's one thing where it isn't necessarily best. So I'm going to talk about what? I'm going to talk about what I am going to talk about, and then I will talk about it, and then I will explain what I just said. What I just talked about. And this is a classic pattern. This is how you do talk if you have more than 5 minutes, which is why 5-minute talks are very good, because then you only got space for the I tell you part. But when you need to fill an hour, you do it in the 3. This is a pattern. It's not an anti-pattern. It's a pattern because it actually works. Besides the kidding, the reinforcement from the repetition in this case is a positive thing because it helps you retain and it helps the speaker think about and focus about what's really important within their talk. One bad thing I will do in this talk, I want to give many concrete examples. Since I'm talking about bad API design, any example I give will be a bad example. So I make them up. Because if I give real-life examples of bad API design from actual open source projects and so on, I would only make more enemies, and I don't need any more. I've got plenty. So the only thing, according to the harassment policy, the only example I'm allowed to give are about design errors I made myself, so I don't have any problem finding a lot of examples of that. And I think there's a second footnote. If something is obviously indefensible, I'm allowed to poke fun at it. The only example I found was the Windows API, but I'm sure we can find out. So, what's an API? Well, I'm not really sure why, but I'm pretty sure the A stands for application and the programming interface part. It's not just about applications. Any piece of software you're writing may need, actually my prediction is will need to interact with other pieces of software, whether it is an application or not. So there is going to be a collection of classes, data types, functions, protocols, events, which allow two pieces of software to independently develop pieces of software to communicate with each other. Whatever the piece of software is, it's a library, a framework, that's pretty obvious. It only exists in order for other software to call it, but also an application, an operating system, a web application, a website, whatever. If it's software, some other software will want to talk with it. And the problem is that the API is developed as part of the software that's going to be talked to. And so wise developers, the guys who are worrying about functional richness, bug-free software, user interface, and so on, are supposed to be the ones who are also worrying about this API thing. What's an anti-pattern? Anti-pattern is it's not the reverse of a pattern, it's a subset of patterns. It's a category of counterproductive behavior that is systematically repeated. It can happen in anything. There are good habits and bad habits. In a sense, anti-patterns are bad habits, just like the normal sense of patterns, like design patterns and so on, are good habits. But it's not just design, it's business project management, programming. When you write up an anti-pattern, you should really give root causes. Why does it happen? Well, the reason of why did you do it that way is always the same one, it's a universal truth. It seemed like a good idea at the time. But the point is, why did it seem like a good idea when in retrospect, you obviously wish you had done it different? So reflecting about it may help avoid the next occurrence. Why is it a bad idea? Sometimes that's not obvious, so you point that out. How does it interact, help, or more often, in the case of an anti-pattern, hurt other patterns or anti-patterns? And what do you do about it? How can you remedy it if it's happened? How can you prevent it, sometimes, from happening in the first place? So, I'm talking about API, design, anti-pattern. So this is the summary of the summary. Sorry, Nita. These are, by far, the most common and worst anti-patterns in API design. Not having an API and not having a design. And then there's others, but you may have too much of a good thing, more than one API for the same piece of software. You can exhibit fear of commitment. To design is to choose. If you're not making hard choices, you're not really doing design. There can be inconsistency, which is probably the first thing everybody thinks of. And it's a bad API because things are done in slightly different ways in different corners, and a lot of more, which I won't be able to do any justice to in an hour. But one general design problem, not only for APIs, but I'm focusing on those, is going to extremes. Instead of striking a difficult balance between competing forces, just focusing on one of them and going whole hog that direction, covering that side of things perfectly, and sacrificing far too much on the other side. For example, how language dependent do I make my API? Well, making it totally language dependent is a horrible idea. Trying to make it totally language independent doesn't work either, as we'll see. Same for should I use standard protocols for this platform, and so on. And then I'll focus on, I won't focus, I will briefly mention the problems with debugging error message, documentation, and performance. As you see, this is not a 1 hour talk, this is really a 1 lifetime talk, but I'll have to just cut off the most important hour. So, worst API design, anti-pattern. No API at all. Because what the root calls, because you didn't think about it. When you had so many concerns when starting the new project, as I listed before, that hey, but what if somebody else wants to call into my application is the last thing you think of. And how do I know it's incredibly common besides by direct observation? I've noticed on the very and deservedly popular site StackOverflow.com, definitely the best question and answer site for general programming, that the most common category of questions fall into how do I scrape a website, how do I fake a user interaction with a website, or how do I simulate mouse movements and clicks and keyboard keystrokes. Why is everybody so interested in scraping websites and simulating mouse drags? Well, some fraction are people who are trying to do very thorough end-to-end integration testing, but that's really a minuscule fraction of the interest in these techniques. By far, most of them are missing APIs. So there is this website which has crucial information which my software needs to interact to, and the only way the website designers thought about how people would get there would be to visit them in person. So my software needs to simulate a person interacting with the site and scrape the HTML and extract the actual information. Whether the API just isn't there or is there but not documented doesn't really make much of a difference. If it's not documented, it's as bad as not being, well, almost as bad as not being there at all. Why is it bad? Well, I deliberately designed my website so that you have to be a real human being, and I check, and if you're not a real enough human being, you're not allowed to look at my data, or whatever. Well, people will find a way around. If you don't supply an API, publish a website with no API, you are starting a fight against all the people who want to integrate that information into their own processing. They're going to scrape your UI. They are, I swear. Or what passes for the UI, depending on whether I designed the site, then it's a leaked UI. Or if your software that doesn't apply to websites. But another example of where you didn't think things properly, if you design a rich framework which doesn't allow enough customization, personalization by the using software, they'll monkey patch that software. That's the hook concept which I presented and will present again on Friday in the good pattern idea. And it's the equivalent for a framework or library of the missing API. This eventually, besides the huge amount of wasted effort on your part to defend yourself against programs wanting to get at that information, and the efforts on the other side, because you set up a war, wars are huge wastes of resources, it also places useless extra load on your system. You're going to bother to do a lot of rendering of information into human visible forms, and the counterpart on the other side is busy is busy destroying the formatting, like scraping and parsing the HTML and so on to get the data which they really care about. So you're doing a lot of work on your website for the rendering part, and they're doing a lot of work to undo your rendering. What a great way to waste computational resources, which in the end mean energy. And, of course, one thing, you will not be able to stop people from getting at the information, but you will be able to make their life totally miserable, if that's your purpose, because every time you decide to make a slight cosmetic changes, okay, this HTML isn't quite as good, so let's make it on an ordered list rather than an ordered list, or whatever, their code break and they have to do it all over again. If you manage to get yourself hated enough by the people who desperately need to get at your data, that's the best way to ensure that your competitors have a chance to do you better. Say you have the best site in the world for X, whatever is X, say real-time result of soccer games. Yet it's so hard to get at that basically even though your data is perfect and wonderful performance and great update and so on, some other organization can offer a site that is about equivalent, maybe slightly inferior, but has a good, decent API. Congratulations, by not having an API, you've just given away your competitive advantage. Now, this may seem more of a commercial consideration, but in terms of competition for mind share, we know it fully applies to open source. I mean, we have this friendly rivalry with, say, Perl or PHP. It's not about money necessarily. It's about mind share. We want people to be using Python because it's better, but we have to sell Python versus PHP or Python versus Perl. So competition matters in this field as well. So what do you do instead of not offering an API? Well, I'm already giving the solution here, but this is probably the most important contribution of the whole talk. Instead of not having an API, have one. I know, it's a revolutionary concept. Pick any API. And it should be easier than a lot of other things you do while designing and developing software. A lot of the problem in doing really great software is that, say, you're doing awesome application for accountants. If you're not an accountant, you work closely with them, but in the end, you're not experiencing first person what is it like for a professional in that field to use your application. If you're doing a weather forecasting site and you're not a weather forecaster, same and so on. Now, when you're doing an API, you're basically serving other programmers, and you're a programmer, so you should know what are they going to be looking for. So it should be one of the easiest tasks in doing software right. Of course, I can see the perfectionist saying, oh my God, there's so many ways to go wrong. I'd better not offer any API because I could make mistakes. Yes, but one with problems and weaknesses is better than none at all anyway. And please document it. Don't think that just because the code is there, you're done. If writing documentation is, in your worldview, cruel and unusual punishment, I sympathize. A lot of software developers think that way. At least provide copious examples. Writing example of code using your API may actually be more natural, easier for a programmer than writing Italian text or English text or whatever to explain exactly what's going on. Once you do provide documents, please make sure they're up to date. If there's one thing worse than no documentation at all, is documentation that lies to you. Disinformation, disdocumentation. And that's another advantage of providing a lot of documentation in form of examples. You can test it. If the documentation is in English or Italian, it's kind of hard to automatically realize that you're lying. If it's runnable code examples, it's just one more test. That's why we have doc test in Python. So if you'd rather do something else, but I have convinced you that you need an API, these are a few tips about making your life easier. Follow the path of least resistance. It doesn't actually lead to bad. It may lead to okay, tolerable, and it's far better than nothing. Just go with the flow. If you have a web app, it should be representational state transfer. It should use JSON. If it's on Windows, I'm sorry for you, but if it's on Windows, it should be COM. I realize Microsoft doesn't want you to do that anymore, but it's still the de facto standard. If it's a Mac, you do the AppleScript thing. Doesn't mean you actually have to learn any AppleScript. There's a reasonable, well-documented API for that. I wish I could offer a similarly obvious suggestion for Linux. There isn't a single dominant standard the way there is on others. My preference is I listen on port whatever, say 8080 anyway, and go back to the web app thingy, but that's because I think web. And doc test for the documentation as form of examples that you can run and so on. So this no API at all is worst. Second worst is no design. An interface that was never actually designed as an interface. That just happened. That's another side of they didn't think about it in advance, just like not having anything. And the second point is, okay, I did think about it, but designing the interface is work. It's hard work. Well, semi-hard. There's worse. It's interesting. By the way, when you do get down to design, think about, again, put yourself in the user's shoe. In this case, the user is another programmer, so it's easier. What would you like to use if you were outside this software system looking in? So, given the resistance of adding yet another task to all the stuff you need to do when you do software, you go for, oh, wait, I don't need to do an API. I already have one. There's a user interface and a backend, and they talk some internal protocol, whatever. I'll just publish that, and maybe if you're very, very lucky, document it. Or, but I'm fine because I'm already writing to a database, and I just published the schema of the database, and hey, I have an API without any work at all. And I'm sad to say that probably half of those APIs that do exist give clear indication of having developed in this way. Why is this bad? Because if you haven't designed what exactly you're exposing, you're basically exposing the internals, the implementation details of your code. What happens next year when you find a better way to perform the same functionality? You want to change the internals. Well, either you don't and give up your improvements forever, or you break all of your clients, great way to make friends and influence people, or you shoulder forever the burden of a dual implementation. There's a real API, there's a real implementation, the way things actually work now that I've thought of a better way, and there's the API way, which it used to work kind of that way last year, and we need to keep maintaining because a million scripts and other programs interact with it. So what do you do instead of no design? You do two things. You think about your API. Remember, focus. If you were the programmer on the outside, would you like to use this API? Would this meet your needs? Would it make you happy? And then you forget the implementation part. That's hard because you're like writing it, but forget about it, forget the details, and look at it at a more abstract level. Think about what? What would I want to be doing as an external programmer to play with this software system? Why would I like to do that is also helpful, but how is crucial, but why is helpful. And don't just think we're human beings mostly, and so abstract thinking isn't really our strong point. walk a mile in their shoes, literally, write scripts, write programs that use the API you're designing and see how well does it work, does it work smoothly, and so on. I would actually like every program, every software system to have a core part which exposes an API, and everything that can go on the other side of the API, all the auxiliary parts of the software should actually use the API. This will guarantee at least that it's functionally very complete. Normally, I would never, for like the vast majority of where is in software development, I would never recommend thinking about things before writing code down. Put down a prototype, play with it, change it incrementally, release early, release often. I strongly believe in all this except for two things, security and APIs. Those are two parts. Well, security because there's this unhealthy interaction between you and the would-be hacker, and so there's an interaction with another programmer, in this case an adversarial one. API because there's a potential interaction with another programmer, which you are trying to keep a friendly one because you're working for the same goal, serving some end user. And so they need some forethought, a lot of forethought actually. So I recommend you think about those things, and I recommend you forget about your current implementation. Given that it is a running implementation, it's chock full of very specific details. Those specific details are accidental. They're the accident of reality. What is really important and what your API should focus on is the concept. What is the software about? What is the objects? What are the verbs? And one way I found productive I'm not talking about spending months on this, but one day of 2-3 people and a whiteboard. Put the computer away. Just whiteboard and dry markers. And brainstorm about what are several possible ways we could implement these concepts. What's in common to all of them? They all deal with, I don't know, soccer games, or so there's teams, and there's results, and there's past games, and the teams may have met in the past. Do we have those statistics? Oh, wait a second, players are important too. Do we care about who's the goalkeeper for this? What teams was this goalkeeper playing with last year? These have nothing to do with how do I code this or how do I put it in the database. It's got everything to do with the concepts my website, in this case, is bending about. And I think of several ways of implementing it. What's in common to all of them is the substance of my program, the substance of my software system. It is what my API should be entirely focused about. So why would you want to do all this work? Well, first of all, it's very fun work. It's for once, you're not really caring about what would the accountant who's supposed to use this need and so on. You're thinking about what would I want as a programmer to use this well. Plus, the return on investment, it's a substantial investment. The return will amaze you if you've never done it properly. Not only, of course, you get a better API, you get a better software. By thinking in this, by being forced to think about the distinction between substance and accident, you end up with a better structure. In particular, even in terms of end result as code, you end up with the core that does as little as possible, and everything else is external subsystems, which is a great architecture for any software of substantial complexity because it allows you to upgrade one bit or another as long as it's not part of the core in the smoothest way possible. My favorite example, and yes, I do have permission, the XKCD guy is the most incredibly cool person, for Bait API, which is why I was sure to talk about exposing the database, is the very worst case of exposing the database is exposing it accidentally, without realizing you're exposing it, by taking some strings and just using it and allowing that string to hide SQL or whatever your database language is. So note that this isn't just about terrible API, it's also about security breakage. So you're designing in both, what they have in common, what security and API have in common is you're thinking about another programmer. I already said that, but I did alert you that I would be repeating the core concept. In one case, the other programmer is an enemy. In the other one, you'd rather they wouldn't be an enemy. You'd rather have them as your friend. But this is in common. There's another programmer on the side. Okay, those are the two biggies, but now we go faster about minor issues. 0 APIs is too few. 3 is too many. 4 is right up. 1 is usually best. Sometimes you have special consideration, like you really need an application level plus an administration level, for example, for an operating system that's not unusual. It's somewhat unusual for like websites or things, but if you ever do OSs, okay. Why would anybody, I mean, hey, I spent half an hour explaining why people do too few APIs. Why would anybody do too many? Well, the main cause is transition. Okay, I did it wrong. When I released my software last year, it was incredibly successful. I've got a big gazillion people using it. Still, the API is a disaster, and now I know how to do it right. Do I fix that without, for some time at least, having the bad old one, which I need to keep in order to not break a million clients, and the new one? Or similar transition between APIs, the number one, but another one would be, I used to have this great API, but it's PHP only, and now I'd also like to support people using Python or Java or something else. And the second cause we'll talk about in the commitment issues is unwillingness to decide. You end up doing things two ways when one would be perfect, simply because either way seems good and you can't decide. And another one, I haven't really seen that much in open source, but it's very common within a firm. There's organizational structure. There's an old saying, I think it was Niklaus Wirth, you can tell a lot about how the department is organized that's written a compiler by seeing how many passes the compiler has. Remember, this was the 60s. If it's a 5-pass compiler, I bet it's been the work of 5 university departments. It's a natural way. Okay. If some complex software system has 3 differently conceived and partly overlapping APIs, you can kind of tell there's 3 groups, 3 kind of independent groups working on the software. But that's more common within a firm, although it can happen in open source. So why is it bad to have many APIs? Well, there's a lot of extra work in keeping them all working. It's maintenance. Bits decay unless you work on them actively, without any benefit to anybody, really. And you don't get to refactor things. It's not really helpful for that. And the user, far from being helped, is damaged, is getting confused. Okay, so I can do it this way or that way. And sometimes there are things you can only do through this route and other things that you can only do through that route. If you need to do both, you end up having to mix and match to incompatible APIs. The transitioning part is really, really hard. What I would recommend, if you do it right from the first, which is not a given, is layering. Layering is okay. You can have a low abstraction layer that is Still not too close to the implementation, but close enough that it doesn't have, it can expose nuts and bolts levels. It's not talking to the application level programmer so much. User unfriendly, hard to use. As long as it's well documented and well debuggable, you're going to be fine. And then you can build other APIs, and in this case, it may be even okay to have more than one, on top of the lowest level. Why does that work? Because the only maintenance needed, is, as the implementation evolved, is for that one layer. But what if you didn't do it right the first time? Well, then, I'm sorry to say, you need a plan. If we're programmers, at least those of us who are programmers as opposed to project managers, are probably going to run away screaming, but in this case, to err is human. To not plan how to fix your error is diabolical. Big bang transition is right out. Please don't do it. I mean, look at what happens every time somebody tries a big bang transition, including languages like Perl and Python. I mean, I don't know how many of you have totally transitioned to Python 3, but hey, we haven't had, so we now have Python 2, Python 3. It's like these two things will live together for a year. Perl 5 and 6 is in an even worse shape. The big bang transition is really painful, so if you can possibly avoid it, please do. So what you need to do is phase out, phase in. Have at least one release, better more than one, where the old stuff still works and gives more and more strident warnings. It's like, hey, you're doing things the wrong way. Use this way instead. Or, ideally, specific suggestions. Make sure you absolutely need to invest in tutorial and other kind of documentation. How do I transition? Never add new functionality in an old API. This at least is something Python has done right. Python 2 will never have any new cool stuff. So that is a motivation for all of us to, I really, really need to move to Python 3 because all the new hot features will be there. And sometimes you can even tweak the design with care to help the transition. So fear of commitment is the let's do both syndrome, as in this well-known Dilbert strip. So shall we build a product that nobody wants to use or get sued? Let's do both. Why is it bad? Because you really need to decide, and that can be scary. Because once you make a decision, you're accountable for it. And especially in a commercial situation, you may know that if you don't decide, you're not going to get punished. If you do decide and it works, nobody will remember. If you do decide and it's wrong, you're in trouble. So this, I think, is a good example. The Unix example of open is very sharp, of course, but it doesn't let me do this and that. No, it does one thing. In the API, what if we also want to tweak securities? Yeah, what do we need for security? A lot of stuff. Let's pass yet another pointer to a structure, but it can be null. The pointer can be a null pointer. So another bad example, this is my code, my design. Gympie, I couldn't decide whether to make all sort of stuff, freestanding function or methods of objects, so I ended up doing both. Fortunately, we're fixing it now, thanks to Kees van Horsen, who's now actually doing most of the development. It's called Gympie 2, so the old Gympie will say this is, in a sense, a big bang transition. At some point, we'll stop adding any new feature to Gympie. Everything, Gympie, by the way, in case you don't know, is the unbounded precision arithmetic package for Python interfacing. Used to be GMP, but now it's mostly MPFR if you're doing floating point. To decide is human. Ken Thompson was asked, if you were to design Unix all over again, what would you do different? And it's a add spell create with a trailing D. Besides being correct, it's wrong. What he should have done, he shouldn't have had create at all, because open does create's work just as well with the appropriate flags. And that's, I don't know if you program a lot to the bare Unix interface, but when was it the last time you called create without the trailing E? You never need to. You use open. Perfection is not this world. That doesn't mean you shouldn't even try. So have the courage to choose, and if that's a career problem in a firm, work elsewhere. Google is hiring, by the way. An empowering environment, a place where you are encouraged to fail. As long as you fail fast, realize a mistake, and do it right the next time, don't be paralyzed. Launch fast and iterate, rough consensus, and running code. Inconsistency, we're all familiar with those. Sometimes the argument ordering gets changed. Some things are spelled one way. I'm looking at the Python standard library. Can you, unless you've totally memorized it, do you know exactly where do you need mixed case and where do you need? One of my favorite things to hate is how you treat acronyms. Have you ever noticed that, the acronyms are all uppercase. So when I read HTTPS all uppercase, that's how I parse it. So this is an HTTPS interaction to end a query. What? It reads that way. No, wait. The first HTTP is the acronym, and the send is a different thing. And okay. Why does inconsistency happen? I don't think it's because people are too fond of reading Ralph Waldo Emerson. Foolish consistency is the hobgoblin of small minds. Rather, I think because people change over time. So they start one way, and then they think of something better, but the old stuff stays the old style, the new stuff goes to the new style. One example I just gave, that's an actual example from an interface. There's, how do you call it? Commit transaction, singular, versus rollback transactions, plural. They both take a list of transactions to commit a rollback. So why is the spell difference? Well, because historically, commit transaction came first, and it only took one. So when the rollback was added, that was extended to take several, but the spelling problem remained. Or different people conceptualize things in different way. My recommendation, and I know this cites me as an old-style IT guy, but a data dictionary is actually a good idea. It's called a data dictionary traditionally, but it's not just about data. Verbs are just as important. A one-to-one mapping of word to concept that applies throughout your system. Whenever a new concept arises that wasn't exposed on an API before, add it to the data dictionary before you start coding. So this makes something go away. How do we call that? Erase. No, delete. Okay. Either is fine, I don't care. But just call it in the same way forever. Making something go away is called, in this software system, is called delete, or maybe it's called remove, but the point is it's called in one way, not in three different verbs, and so on. What it costs is a little more work to coordinate, but it's well worth it. It's like having a coding style for the team. You make a little upfront effort to set it up, but then afterward, there's so many fewer trivial decisions you have to make. Okay, this makes the thingy go away. How do I call it? Delete or remove or erase or go away or nuke or wait. Well, you don't have to think, waste a couple minutes and energy and distracting to choose this. Just say, okay, how much do I indent here? 3 spaces or 5? You don't have to. You made that decision at the beginning of the project. It's written there. We use 4 spaces indent. That's it. It's better to have decided it for once. It doesn't matter whether it's 4, 3, or 5. Well, in Python it better be 4. But the point is, it's there. It's a trivial decision made once and for all. This isn't exactly trivial, but it's better to. And that's why it saves. Okay, avoid extremes. They're very tempting because they look so sharp and strong, but there's always a downside. Extremism is simpler, but it never works as well as balance and good taste. For example, what programming languages are we supporting? Well, one extreme is, of course we have an API. It's all, Brainfork is an interesting variant of a language that spells similarly, and I can't say in public, but with an addition of forking off multiple tasks to make it even more mind-killing. So anyway, so of course anybody who wants to interact with our project just needs to learn this language and code them. Whatever language you use to implement your system should not influence your API. That's absolutely crucial because it's one of those internal things. Hey, tomorrow I recode it in JavaScript or whatever. That shouldn't make any difference to people calling into the system from the outside. So this is very important. Avoid data exchange through language-specific format. Pickle is evil. Don't expose Pickle as your API. Yes, but everybody should be using Python, yes, but some of them will have to be using JavaScript because they're running in a browser or whatever. Don't force them to go to your competitors because there is no good Pickle implementation in JavaScript, and there will never be, I suspect. Use something. JSON is not language specific. You can parse it in any language. It's very, very easy. Other formats. The other extreme would be, well, you can program Fortran in any language. So have no object-oriented anything, nothing except arrays. That's pushing things too far. If people do want to program in Fortran, you can say, okay, you just need to use Fortran 97 or maybe Fortran 2015, whatever. I'm sure there will be some language called Fortran that has whatever set of features you want to expose, so it's not a problem. So object, structures, and so on, you should really be using. Don't invent yet another data format. It's not particularly evil, but it's such a stupid waste of time. There's so many. Have you ever thought JSON or its superset, YAML, that's actually got very useful enhancements, isn't it good enough? It mostly will be. If it's not, have you considered CSV, FITS, HDF, NetC? I mean, there's so many. That's a good thing about standards. There's so many incompatible ones to choose from. But that wastes too much space. Well, use Google Protocol buffers. We open source them for a reason. No, it doesn't waste enough space when they use XML. Hey, you don't have to invent your own way to waste space. People have done it for you. It's very effective. I want to hear your excuses why you need yet another incompatible data format. No, actually, I don't, but I don't actually want to hear the excuses. But if you're on the web, why aren't you using REST, as in representational state transfer? If you are not on the web, why not use REST anyway? I mean, it's so easy to listen to port whatever, 8080 or something, and get your API that way. It's a great way. Even if most of your functionality has absolutely nothing to do with the web, I would seriously consider it, except if you're on Windows or Mac, as I already mentioned. And then there's far more general stuff like RPC, Corba, and so on, that sometimes can pay for themselves in terms of generality. Debugging. Error messages and documentation. When you make an API, somebody will be developing with it. One hopes. Otherwise, your whole exercise has been somewhat futile. They will make mistakes. They're probably human, most of them. You will make mistakes. I realize that's very hard for programmers to accept, but we do. Occasionally, rarely. I remember once in 1980, that I actually made a mistake. Well, I came close to making one. Open source helps because they can get this mysterious error message and start digging into the sources to find out why is it saying that. But it's really, you shouldn't rely on people getting incomprehensible error messages or no documentation and deconstructing your sources. It's really wimping out. It's like the kind of software where you get the error message is there was an error. Okay, which error? Can I have some indication? What did I do wrong? That also applies to user interfaces, but that user interface is not my field of expertise. API is. So documentations are hard to write, but they're really the most precious part. Just keep them well aligned by testing testing documentations means your documentation is runnable code examples. That's a reasonable way to communicate, and it has this huge advantage that it won't go out of sync with what the software is actually doing these days. And then, last but not least, there's performance. Most people who do great APIs in many respects forget this one little bit. If the API doesn't have some performance issue in mind, in some context, it can really kill you. For example, if the API is, okay, you build an object like this for the purpose of calling one method on it, and then the object goes away, depending exactly on what we're speaking about, can have a lot of object construction overhead and object destruction overhead, which really isn't all that justified. So consider that kind of thing. If every call, that's especially true if, for example, you're going through the web, so a round trip means hundreds of milliseconds of delays going for the request and with the results coming back. Suppose, again, that hypothetical website about soccer, so you want to know which team did this player play with on that year. You actually want to know which teams he played with in 10 years, so you shouldn't have to do 10 queries. One, what about 2009? What did he do in 2008? What did he do in 2007? A lot of APIs are designed like that. You should be able to pass an array. These are the years I care about. A single transaction, save hundreds of milliseconds each time, it mounts up. In some cases, especially in a cross-language environment, supporting threading and distribution can be hard, but and also asynchronous use, it can be very important for performance and scalability. And mostly in scientific work, array computation, if you try to give very precise guarantees about behavior under error condition, that can really kill your performance. What you want to, divide array A by array B, as soon as there's a zero in array B, everything after that is not done. That's very hard to ensure without completely serializing and thus losing the point of an array interface. Okay, this is the fast version of, as I said, what should be a lifetime talk, and we do have a little time for question and answer, if there are any.
You mentioned the example of Kriat. You don't need the Kriat because you can have open. But the counterexample for that would be malloc versus free versus realloc. Realloc can do the same thing as both malloc and free. So there's a trade-off between having more things in one function or things in other functions because it's more error-prone to have, in the case of realloc, everyone using realloc. What then are your guidelines for how to determine that? I personally like to test this against users, but early on in the API development, there's no beginner users using my API.
So I think the layering concept really helps. If you have an alloc function which takes 7 parameters, that's not easy to use, but that is the zero-level API because it lets you do anything regarding memory in the unified way. And then you publish a layer 1, which distinguishes malloc from realloc and so on, but it's entirely implemented in terms of the lower levels. This is not the kind of overhead you should worry about, like, oh, but there's an extra function call, especially in C. Who cares? It's not going to kill your performance. And anyway, the level 0 interface is available, published, documented. It's just not the most convenient to use. When you're designing an operating system or equivalent, now create versus open is typically OS level, malloc, realloc is typically, but it's still low level enough that that it might as well be an OS. You shouldn't expose several different ways to do things for convenience. That's
Which is higher and lower there? Is realloc higher or lower than new?
Neither. Alloc would be. I would recommend having an underlying thing which takes all the realloc arguments and more, like a flag asking for specific behavior in terms of...
But then you have realloc, alloc, and free at the lowest levels, and then realloc being...
Actually, free should be part of alloc. Think about it. Maybe alloc is therefore not a good term. Do stuff with memory would be a good name. Okay, let's...
Sorry. So you try to give advices as to how APIs should be evolved in case you design an API and then it's not as ideal as you would like it to be. So you basically have a second API. How about versioning? Would versioning APIs, does that help with evolution?
Okay. What about versioning? Well, it may help avoid confusion, but it doesn't help avoid having to maintain multiple versions, especially if they're incompatible. It's like, I realize Python is not an API, but you know whether you're using 2.6 or 2.7. There's still maintenance needed on both versions. It's not really that...
Sure, but like you can also retire versions, and it helps people transfer or...
You can claim you're doing that, but it doesn't help them transfer. Like in Google App Engine, we're still using Python 2.5. Not particularly happy about that, but we are.
I can think of languages or libraries and frameworks where there are like hundreds of functions without namespaces or very heavily polymorphic methods, and I don't think those are really good API decisions, but they are hugely popular. And I wonder if they are being popular because they are used by programmers of various levels of experience, especially beginners, or like there is a new application domain, a new language, or there is the web, and there's the iterations, first generation of software is not optimal at the API side. Or we should worry if we have a good API that allows for asynchronous, multi-threading, and performance, and that will impact our popularity.
I think the best answer was given by Albert Einstein. Everything should be as simple as possible, but no simpler than that. Seriously, complexity for its own sake is horrible, but trying to simplify complexity away only works when the complexity is superficial. Sometimes you have problem spaces that have inherent complexity, and then the attempts to simplify that away end up leading to more ambiguous complexity. So finding out exactly how simple is possible is a really, really hard problem that I can't address except in very specific spaces. But that's exactly the kind of thing where effort up front, again, put the computer away, get a whiteboard, and 3-4 interested people, ideally not all programmers. Some will be the domain experts. It depends on what your application is doing. They may not be able to write Python or JavaScript or whatever, but they sure know what matters in tracking soccer games and so on and so forth. And they will have better suggestion of what should be modeled, even if they don't know what a polymorphism is and think there's probably something to do with Greek mythology, which I believe there is some of that, or biology.
Hey, Alex. Your GM PY example, I didn't follow what the issue was there. What was it that was done incorrectly in the first
They,
pass and what needs to be fixed?
essentially all of the functionality in GMPY you can access in two ways. You can call a freestanding function from the GMPY module. So, I don't know, you want to find the lowest set bit of a number, you can import GMPY dot, I forget how it's spelled, low bit, of X. And it says 3, meaning there's 3 zeros, and then there's a 1 when you go right to left. Or you can build a GMPY MPZ instance, so y equal GMPY MPZ of X, and then that one has methods like low bit. So you can access it by calling the methods there. I couldn't decide what was more convenient. In an unusual excess of humility, I'm normally more prone to the other, to err on the other side. I decided I was not worthy to decide whether to have stuff presented as methods of instances, which required to explicitly construct the instance and then call the method on it, or freestanding function on the module. So in GMPY2, almost everything except a few where specifically we identified we don't want to tie them to an instance is instance methods, and the freestanding functions have gone away, mostly.
Would you care to comment on the way Python spells the same function two different ways, open and file?
It seemed a good idea at the time. Nope, forgot to.
I'm going to throw it.
So you said you didn't want to mention any real-world examples because you didn't want to make enemies. But do you have any real-world examples of really good API design that you find like, ooh, this is nice, that you want to make any friends?
Maybe it's because I have worked with it as opposed to inside it, so I have the outside view. But I really think that the vast majority of the subsystems in Google App Engine, the Python side of it, I'm not really familiar with the Java side, are really well designed. I like to use those and maybe implement, if the actual underlying server is slightly different, I think that's a good symptom of when an API is designed really well. It's like, I'd like to use this API even though I don't care about the implementation in this case, but hey, I can re-implement. So this is a simple way to send mail or react upon receiving mail for any web server. And of course, your web server is implemented on top of some other stuff, but you'd still like to program to that. I think that's a good indication of whether it fits your brain. But there is some subjectivity to it because, like, some people get very used to it. They can't. We eventually ended up re-implementing, for example, some old ways that were socket-based. You can't actually open a socket in App Engine. It's a bit sandboxed. You realize that. But what you can do is open a URL. Yet, we had to re-implement the simple open a URL idea so that it looked more like the old Python socket-based ways of doing it, simply because people were used to that. But I think, so there is multiple ways to visit a URL, but I think the native one is the well-designed one.
Where can we buy that T-shirt? It's fantastic.
You should come to PyCon US every year at PyCon US. Next year it will be in Santa Clara, California, so I'm supposed to help organize it. We have this vendor called Fine Threads, something like that. I think you can probably find them online. Anyway, he's got this lot of great stuff, Python branded. He's got PSF permission. I keep trying to tell the guy, it's a family-run firm. It's a father, mother, one daughter who work out the thing. You should come to EuroPython. You should. It's a small American firm. It's a big expense for them. They're a bit afraid. So you come to PyCon US next year in Santa Clara and tell them, I agree, it's awesome stuff. That's why I own a lot and wear it off.
Unfortunately, we don't have more time for questions, so it's time for the coffee break. You can get out from both exits and follow guidance.